Okay, in this video we're going to be doing this problem. So at first, let me just take up a pen. Okay, here you go. So this is the problem that we're going to be doing, and we're going to neglect the axial deformations, and we're just going to find the displacement values. So you can see that there are three members in this frame: member AB, member BC, and member BD. Okay, and member AB and member BC are of 5 feet, but member BD is of 10 feet. So there's going to be different values for that because of the length. Okay, now if we go on to solving them, we can see that both A, C, and D have fixed supports there, meaning there are going to be no displacements or deflections there. So the only displacements that are available here are, let me just go to another page. Okay, we'll start from here. Or maybe we can just do it here. Okay, let's just do it here. So the only available displacements here are the VB, the UB, and the theta B. Now we have said that we're going to neglect axial displacement. So if we neglect axial displacement, VB becomes 0, UB becomes 0, so we're only left with theta. So theta B is what we're going to find. Okay, so let me just erase all this. Okay, theta B is what we're going to need to find. So let's develop the matrices. At first, let's develop the matrix for KAB. So at KAB, we had 1, 2, 3, which are 0. Then we had 4, 5. So the theta value is at 6. So 6 by 6. If we go 6 by 6, we're going to get S3. So this is what we're going to get, S3. There you go. That's theta B. Alright. Very good. Now we're going to do it for KBC. Okay. Let me take up an eraser. So if we're doing KBC, then the number is going to be 1, 2, 3. So theta value can be found in 3 by 3. So here is 3 and here's 3. So 3 by 3 is also S3. So we get S3, theta B, theta B. Okay, wonderfully done. Now right after that, we're going to go for the last member of ours. And the last member is BD. So B comes first. So again, 1, 2, and 3. So that's also going to be 3 by 3, which is S3. So we have KBD equals to S3. But this time it's not S3, this time it's S3 prime. Because the member length for AB and BC were 5 feet, that's why the S3s remained S3. But since the length for member BD is 10 feet, not similar to the before lengths of AB member and BC member, the S3 value, the stiffness value is also going to change. That is why we're denoting it with S3 prime. Now here are the S3 values. So if E is equals to this, A is equals to this, and I is equals to this, we can get out S3 value, which is 4 EI by L. Here the L is here the L is 10 feet. There you go, 10 feet for member BD, and S3 prime. So let me just change the annotation. Let's say this isn't S3 prime, this is just S3, and this is S3 prime. So if it's S3 prime, we're going to get the length is going to be 10 feet, and we're going to get 20,000. And S3, for the regular S3 of AB and BC, we're going to get 4 EI by L, where the L value becomes 5 feet, which results in 10,000 feet per radian in stiffness for S3. So this is what we have. Now we're going to formulate the entire matrix, the K main matrix. There you go. The main matrix is also theta B by theta B. It's not that hard to formulate. So we have 2 S3s plus an S3 prime. There. It's theta B by theta B. Okay, So we have got the value of K for determining theta B. Now we're going to look at the value of Q and the F. So at Q, we can see that there are no moment values at B joint, so it is 0. And for the F value, let's calculate the F value here. If we were to calculate the F value, you can see that at B point there are some moment forces here. So this force is going to cause something like this here and here, and this values are going to be PL by 8. So if I do PL by 8, I'm going to end up with something like 6.25. So P is 10 kips, L is 5, so PL by 8, let's do it. 5 into 10 divided by 8 is 6.25, yes. So we have 6.25 positive and 6.25 negative. So this negative value is associated with our B joint, so this is going to come into action. So here we write negative 6.25. Similarly, we have another member for which we'll have to calculate the moment. You can see we are not taking a fixed end reaction here because we are determining theta, and theta is associated with moment, not associated with forces. That's why we're not taking the fixed end forces. And we also did not take any Q values because there are no moment values here. If there was external load value here, Q would have been 0 because we are determining theta B, and theta B is a rotational displacement, and rotational displacement is only associated with moment values, so force values are not going to have any effect on it. Okay, so if there were an externally imposed moment value here on B, then Q would not have been 0. Okay, so let's move on. Where were we? So we got minus 6.2. Now for member BD, remember to calculate this, what a trick you can do is always put the UDL on the top. So if we put the UDL on the top and make this member horizontal, we'll end up with something like this, where this is B, this is T, and here is WL squared by 12, here is WL squared by 12. Okay, now if we again rotate this thing and place it here, we're going to get some kind of a anti-clockwise moment here. Okay, so if we are getting an anti-clockwise moment here, meaning that is a positive value, and WL squared by 12 comes out to be 16.67 because the W value is 2 and the L value is 10. So this is since it is anti-clockwise, according to our sign convention, this is going to be positive. So we write a positive value, so which is plus 16.67. So we got the K value, we got the Q value, we got the F value, right? So we can easily determine the deflection right now. So now if we were to determine the deflection this time, okay, let me just fix this. Nothing there. Okay. Now to determine the deflection value, what we need to do is we need to do the KU equals to Q minus F, which you can easily do here. So you know the Q value, the U value is only theta B. You know that it's only theta B. Place the K value here, place the equal to Q value is also 0, so we're just gonna have minus F. So K theta B minus F. From here we can easily get the value of theta B. Okay, all right, so do try this yourselves and try to finish it and see what the results you're getting. Okay, all right, so yeah, that was it for this video. Thank you very much for watching.